Hello, Drew's Custom Creations right here. So, all of you probably know about pi if you've ever been in a high school or middle school class. It's pretty important. I mean, you can find anything out about a circle just by finding the radius of it and also by finding pi. The thing is, though, is that this thing is huge. In fact, nobody's been able to find pi. I mean, the closest we've gotten is 62.8 trillion digits in, and we're still going. No, I'm not talking about this pi, although I would like some of that right now. I'm talking about this kind of pi, the kind that you calculate with computers. I mean, sure, usually in order to be really accurate and go to that 62.8 trillion digits, you're going to have large banks of supercomputers. However, you can do the same thing just with your regular computer. I mean, I'm on a Chromebook, and that's not exactly known for its computing capacity. And so today, I'll show you how to calculate as many digits as possible with the random point method in Python. No, I'm not talking about you. Get out of here. So, random point method. What the frick is that? So many of you probably know about calculating pi by finding the circumference of a circle and then dividing it by the radius in order to find pi, because pi times the radius is equal to the circumference. Or it might be 2 pi times the radius, or pi times 2 times the radius. I'm not sure. I just learned that in 6th grade, so I don't know. Anyway, circle has to deal with a lot about circles. So with the random point method, it is a lot easier to calculate pi, and it's a lot easier to do it more accurately. Because you see, with the problem with the one where you're dividing those numbers, you have to measure the circumference of a circle by hand, and it might seem pretty easy at first, just like wrapping a string around and then cutting it and then measuring the string. But if you make one tiny mistake, then it won't be accurate. However, with this, you can just mathematically calculate it, and you don't have to worry about measuring anything. So, again, how does a random point method work? Well, you see right here we have a circle, and it's inside of a square. So what we do is we put a random points inside of the square, like this. And after we've done that a lot, we figure out the experimental probability of getting a point inside of the circle. What's experimental probability again? You probably learned it in pre-algebra, but that might have been a while ago for you. So I'll tell you what it is. Basically, what it is the probability of getting this point inside of the circle according to what you've done experimentally. Now, you could just calculate the probability of it, but you could also use experimental probability by putting a whole bunch of points inside the square and then seeing how many of them end up inside. Now, anyway, if you want to calculate the probability by hand, you usually use this equation. Probability is equal to the area of the square minus pi times the radius squared. What this does is it first figures out the area of the space outside of the circle by calculating the area of the square and then subtracting the area of the circle from it. And then after that, well, you get the probability of it getting inside of the circle. Anyway, what you're able to do is you're able to reorder the equation so that you have pi is equal to a whole bunch of numbers. And right here, this is the official equation for the random point generation stuff. If you reorder the equation, you probably won't get exactly this. But basically, it is the points inside of the circle times 4 and then you get that, and then you divide that by t, or the total points. Anyway, by using this, we can mathematically calculate pi. Now, of course, if you're putting a whole bunch of random points in, it's not going to be completely and totally accurate. However, the more points you put in and the more you calculate, the closer it will be to pi. Okay, so right here I'm in the program, and as you notice, the screen looks a little bit different, and that's because this program best works on this website. Now I'll tell you what it is. There we go. So you can see right here, I have the link up. You can just pause right now and copy down the link on a piece of paper. I'll try to put into the description, but I found that doesn't always work for some reason. I don't know why. YouTube's weird. But, well, here it is. Now let's get right into the program. So as you can see, as soon as we start it, we get a prompt for accuracy. And basically what this is doing is we're typing in how many points we want to throw it in at our square. So I think this time we will do 1 million. And right here it's showing how far it's done by showing the percent. Got a few weird numbers right there. Haven't figured out those bugs. But after a while it calculates pi, and it's pretty close. Instead of it being 3.14, it's 3.13, but it rounds to 3.14 because it's 3.13924. So yeah, pretty cool. Now, enough stalling. I really need to show you exactly how to code it. Now, of course, I will be showing you this entire video how to code it, but I'll also put the code in the description of this video too. Okay. So right here I have an empty compiler command prompt thingamajig. And let's just get right into it doing this. I hope you guys enjoyed that high school math. I mean, I sure enjoyed it while learning it in 7th grade. Ugh. Anyway, we have a couple modules to import. I'm not sure if I've talked about modules before or not. Basically, Python is an ever-growing language. And so people keep adding stuff onto it every day in the form of modules by coding stuff in and posting them onto the internet. And you can actually import these modules, which will modify the original Python language so that you can do more things. And you have stuff like Pygame, which allows you to make cool video games. You also have wow, I can't think of any more. But yeah, pretty cool stuff. So first we need to import the math module. Import math, that's how you write it. Then the random module. Import random. And the math module allows you to do more math. In this case, we'll be doing square roots, but you can also find the smallest number in a sequence or the largest. And then import random, which allows you to make a random number. Now we need to, of course, set some of our variables to being certain numbers. So inside is equal to 0. Total is equal to 0. Accuracy is equal to int input accuracy colon So what are each of these variables? So inside is the amount of points inside of the circle. Total is the total amount of points, and then of course we have accuracy, which is also the total amount of points. But they're kind of different. I'll show you in a little bit. Now we need to make a while loop. You guys know how to do that. And if you don't, I suggest going back to some of my earlier programming videos. I talk about stuff in those. Anyway, let's make the while loop. While total is less than accuracy, percent underscore done is equal to the quantity total divided by accuracy, closed quantity, times 100. Checker is equal to percent done times 10. Total is equal to total plus 1. Okay. So the difference between accuracy and total. So total is making it so that the program goes through different iterations until it becomes equal to accuracy. And accuracy is the is the amount of iterations we want to go through. So right now total is equal to 0, but through each iteration it will gain 1 more. And so eventually it will become equal to accuracy, and when that happens, it'll stop the loop. Anyway, total also, by the way, helps you calculate percent done, which shows how far through the program you've calculated. Anyway, let's do our x and y variables. This is basically just saying how far left or right the points are and how far up or down the points are. Remember, we aren't actually graphing these. However, we're pretending to graph these, and we're storing the numbers as if we are. So x is equal to random.randrange -50, 50. I actually don't think I need a space there. Okay, this is just saying it that, hey computer, you can generate any x value that is as far left as -50 and as far right as 50. Then y is equal to random.randrange -50, 50. Same thing, except how far up or down. Now we need to make it so that x and y are squared, because we have to find the distance from the center of the circle, from the center of the graph that the point is. So in order to find this out, you use a Pythagorean theorem. A squared plus b squared is equal to c squared. And so you just input x as a squared, y is b squared. Then you find the answer, c squared. And yeah. So you do that. X is equal to x times x. Y is equal to, y is equal to y times y. Yield. This thing's acting weird. Sorry. Sometimes it'll give you suggestions, and if you press enter in order to go to a new line, it'll print out the suggestions instead. So you probably want to be careful with that in this compiler. And now let's find the distance from the center that this is. Distance is equal to x plus y. So why do we have to find the yield? Why do we have to find the distance? Well, this is because whenever you're calculating this sort of thing, you have to figure out whether the point is inside of the circle or not. And if the radius of the circle is 50, then that means that the distance can be no greater than 50, or else it will be outside of the circle. It'll probably be easier to show you on a graph, but meh. Neither you nor I have the time. Now, distance is equal to math dot square root distance. If distance is less than or equal to 50, so this is figuring out if it's inside the circle or not. Inside is equal to inside plus 1. If checker dot is integer. Hold on. What is checker dot is integer? Okay, so what we're doing it is whenever we're computing how far done this program is with calculating pi, we don't want it to show every single decimal spot. We don't want it to go every iteration. We only want it to tell us that it's certain way through whenever it has gone up 0.1% in this case. Anyway, what this is doing is it's checking it if the checker is an integer. Now, of course, remember I said that was going up 0.1, and for example, 9.9%, that's not an integer, that's a float. Well, remember how it hold on, this audio corrected. Remember how I multiplied it percent done times 10? Well, that's because if it's 9.9, for example, then it'll turn to 99, and that makes it an integer. So this is just checking if this is an integer or not. And if it is an integer, then it's going to print it. If it's somewhere in between, then it's not. Anyway, if checker.is underscore integer, open close parentheses, is equal to true, remember to do 2 equal signs and not just 1. Print percent done, comma, percent done. Scroll down a bit. Pi is equal to quantity inside times 4. Remember that equation I showed you for how to calculate pi based on the experimental probability? Well, here it is in the program. Divided by total. Print 100.0% done, because this will be when the program's finished. Then print pi is equal to comma pi. Woohoo! We did it! Just 22 lines of code too, so I've actually put this on my calculator. It's so easy. But of course, we always gotta run the program to make sure that's alright. So we just press run right here. See? Accuracy. Now we just type in an accuracy. Let's go. Hold on, let's full screen right here so that's easier for you guys to see. 1, 2, 3, 4, 5. This will be 100,000. And there we go. Within a flash, it's done. And it's actually more accurate than a million, which is kind of weird. 3.14604. And there we go. We didn't even have any bugs. But if you had any bugs, don't worry. Just go through the description and see where your code differs from mine. It probably happened because of those weird suggestions. Yeah, don't worry. And you could just look back through the video and listen to my pretty voice. Anyway, in order to stop a program, you press stop, but in this case, it just stopped itself. Alright. Well, thank you guys for watching. Hope you have a great rest of your day. Make sure to like and subscribe, and recommend this video to your friends. Bye-bye.